What's the farthest thing you can see with your eyes? What am I excited about James Webb discovering next? And do galaxies have Lagrange points? All this and more in this week's question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops into your brain, just write it down. I'll gather a bunch of them up and I will answer them here. Now, we do this show live every Monday at 5 p.m. Pacific time. So if you want to get a chance to sort of experience the live show, have your questions answered, chat with me, other people, we do this on the YouTube channel every Monday at 5. Now, you should see the next event somewhere on my channel, so you should have some way to remind you that this is going to happen. But if you subscribe to the channel and you click on the notification bell, then you will get an email from YouTube that'll tell you when the show is going to happen next. And in fact, that is a permanent link to the question show because we make it unlisted afterwards so that we can edit it and release it as the QA. So that's the hack. All right, let's get into the questions. John Kelling. Wasn't there a rocket that had a sort of ejection thing for the crew in case of a failure during launch? What will happen to everyone on Starship if things go badly during a launch? So back in 1986, the Space Shuttle Challenger exploded as it was lifting off, and it killed all of the 7 astronaut crew on board. And after the explosion and after the disaster, NASA pulled together a team of people to look through and sort of investigate the accident and try to understand what happened to make sure that it could never happen again. And one of the things that they realized, and this is kind of dark, is that after the twin solid rocket boosters sort of exploded beside the space shuttle, and as the fuel tank exploded, the orbiter was kicked free, and that's sort of like, the plane part, and was probably intact for a fairly long period of time, possibly even to the point that it crashed back into the ocean and the astronauts maybe were still alive when that happened. And so this was one of the big design flaws of the space shuttle, and they always knew that this was going to be a problem, but with an actual disaster, NASA decided that they had to come up with some sort of solution to this problem. Now, you can't have a escape rocket, like a retro rocket, on the orbiter that would allow it to kick away from the fuel tanks and all of that if there was going to be a problem. So what they decided to do instead was they provided the astronauts with a pole. And so the astronauts would be on the space shuttle. They would, if there was a problem they needed to evacuate from the shuttle, there was only a certain period of time that they could do this. And they would open up the door, they would extend this pole, and then they would sort of clip onto the pole, and they would then slide out to the end of this pole, which would get them sort of down below and away from the wings of the space shuttle. And then they would fall, and then their parachute would open up and they would be able to parachute to safety. But as I said, there was sort of a small window that this was going to be possible. And, when you look at Crew Dragon, especially, and the Boeing Starliner, they both have crew escape capability. So if there's a problem, if the rocket is exploding, there's a reason that they need to evacuate from the rocket, they can push the button and the capsule has its own rockets on board, and it will be able to jump off of the rocket and get itself clear of whatever disaster is unfolding. And it's quite elegant and it works really well, and it's been tested several times, not in a disaster, but it's been tested several times. And so this method of having the rocket having the capsule right on the very top and having a way for the capsule to get away from it is absolutely critical to the largest margin of safety that you want. Now, when we look at Starship, you've got the Super Heavy booster and you've got Starship on top of it. And one of the things that they tested with this latest version of Starship was the ability to do a hot staging. So they fire the rockets of Starship while it's connected to the Super Heavy, and that allows it to escape from it. And so in theory, if there was a problem with Super Heavy, then Starship could fire its rockets early, hot stage away from Super Heavy, and get off the pad. But I don't know, when you think about the size of the Crew Dragon, it's tiny, very low mass compared to the mass of the booster. And so it's able to just leap off the pad if there's a problem. But Starship is very heavy, and so you're gonna need some time for it to get up to speed, to get away from Super Heavy if there's a problem. But that's your escape. And we're recording this before we really truly understand the capabilities, the downsides, the tolerances and all of that with the Starship super heavy stack. If everything goes terrific, then Starship will demonstrate that it works really well, that it's very safe, that there's never a problem, these things never explode, and they're able to carry astronauts safely to orbit and also re-enter the Earth's atmosphere safely. If not, and if they just can't get the safety margins down, then you're probably going to have to look at some kind of alternative way that you get humans into space. Get them to space on a Crew Dragon, and Starships just never carry people. And then once you're in space, then you can have your people come on board a Starship and fly to some destination or go into orbit around something or whatever. And then if they want to come back to Earth, they get back into the Crew Dragon, and Crew Dragon is a very safe vehicle to bring them back down to the surface. So, right now, we don't know how this is all going to play out. It might be that Starship works great and it performs its requirements and it's the one-stop shop to get you to and from space. And it might be that it just never gets safe enough that it meets the kinds of needs that space exploration is going to require. So we're going to have to watch how this all unfolds together. I'm sure you've noticed the Star Trek planet name that's appeared above my shoulder, and this is a way for you to vote, for you to tell us what you thought was the best question this week, the best answer. And the winner was, talk about Triton, please, which I think is great. Like, what a great question. Yes, I love to talk about Triton all the time, anytime, anywhere. So I agree. That was a great question. I'm glad I was able to give an answer. So watch for those names beside every question. We'll have a list down in the show notes so you can see all of the names. And then at the end of the episode, put into the comments the question that you like the best. And that sort of shows like you're watching to the end, you're judging all of the questions, and you're giving us the one that stood out. And it means a lot to us. So, and next week we will vote for the one that, or next week we will celebrate the one that won. Thanks. David Swenson. Do galaxies have Lagrange points? Lagrange point question. Yes. Okay, so Lagrange points, of course, these are the 5 stable points around any 2 objects with mass. So they have to be differing mass. So you've got, say, the Sun and the Earth. You've got the Earth and the Moon. You've got the Sun and Jupiter. And there are the 5 points, the 3 that are lined up between the 2 objects. And then you've got the 1 point that's ahead in orbit and the one that's behind. And that gives you your 5. And here are the rules, right? You've got to have 2 masses that are fairly different. That if they're the same, then you have a binary object and you don't have Lagrange points. And that the Lagrange points themselves have to be able to hold an object that is of negligible mass compared to those 2 masses. So now let's look at a galaxy. If you have just a galaxy, then it's not going to have a Lagrange point. It's like if you looked at the Sun doesn't have a Lagrange point. But if your galaxy has a satellite galaxy, now you've got your 2 masses. You've got the main galaxy, you've got the satellite galaxy, and the satellite galaxy is going around the main galaxy, and so you're gonna get your Lagrange points. You're gonna have the ones that are gonna be ahead and behind in the orbit of the dwarf galaxy around the main galaxy. You're gonna have the ones that's a little farther away from the dwarf galaxy, the one that's in between the dwarf galaxy and the main galaxy, and the ones on the other side of the galaxy at roughly the same distance as the dwarf galaxy. And those are your 3 Lagrange points. Now the 3 that are lined up, they're going to be unstable, and so anything you put there is going to fall away. But the ones that are ahead and behind could be stable. And that would be equivalent to the Trojan regions around Jupiter. But when you think about like the Sun, which is effectively a sphere, and you think about Jupiter, it is effectively a sphere. Yeah, it's a little bit of an oblate spheroid, but it's a sphere. And so the Lagrange points are these very tight, constrained regions around those 2 objects. But when you think about a galaxy, right, it's this gigantic blobby mass, and it's got all of this additional gas and dust that's surrounding it. And the sort of the larger confounding question to this is, what is the effect of dark matter? Because when we look at the rotation curve of the stars in a galaxy like the Milky Way, they are orbiting around, and they don't orbit in the way that planets orbit around stars. They orbit in a way that is as if they are all kind of, at a certain point, they're all orbiting at the same speed. And the only way you could get that is if there's a much larger amount of mass that is sort of enfolding all of the stars, that is 10 times the mass of the stars. And so when you think about the interactions, the gravitational interactions between that main galaxy and that satellite galaxy, you're not thinking about the dark matter. There's probably this gigantic dark matter that is enfolding both of the dwarf galaxies. And so then you've got to think about, okay, we need to get to a place where you've got a galaxy and then its dark matter halo can be kind of considered the one object. And then you've got some other dwarf galaxy that is far enough away that it's no longer in the halo. And it's got its own dark matter sphere. And then maybe you're going to be able to start getting those Lagrange points. But I wonder, like, what would collect in galactic Lagrange points in the Trojan regions as two galaxies, or as a smaller galaxy is orbiting a larger galaxy far enough away that the dark matter isn't missing it out. Midnight lightning. What do you hope James Webb discovers next about? Well, I think the answer to this one is obvious, which is that we're all excited and waiting for the next planets in the TRAPPIST-1 system to be observed by Webb. We've had TRAPPIST-1b and TRAPPIST-1c, but there's 5 more planets, and 3 of them are in the habitable zone around this red dwarf star. And astronomers were hoping maybe that the second planet was going to have some kind of atmosphere, maybe be some kind of Venus analog, but so far the observations are the first planet is airless, like a super Mercury. The second planet is airless, so a second super Mercury. And now you're going to move your way out through the rest of the planets in the system. But we're still waiting. We're still waiting. And so that's the big one. You know, beyond that, I mean, there are lots and lots of other really interesting places. There was a paper that came out, and we reported on it in Space Bites, that a consortium of hundreds of astronomers have put together a proposal to analyze the center of the Milky Way. And of course, this is the region where the supermassive black hole is at the heart of the Milky Way. Wouldn't it be amazing if we got this detailed analysis of the region around the supermassive black hole? Because, you know, we've got these images of the event horizon around the supermassive black hole at the heart of the Milky Way, but what about this environment around it? And like, one of the really big mysteries about the center of the Milky Way is that there are enormous regions of star formation. And, you know, there are thousands of times more stars, like more densely packed with stars in that region of the galaxy than our part. And so here, sure, stars can form and you're going to get planetary disks around them, but they're finding these at the heart of the Milky Way, a place where no one thought that you would get new star formation, and yet there are hundreds of thousands in just one nebula forming alone. And that's a big mystery. And so some really detailed observations from Webb will help resolve that. James Huffman, what's the farthest naked eye object? I would say the farthest one that you can see is Andromeda. And of course, that is 2.5 million light years away. And you can see it. Like, if you've got nice dark skies and you know where to look, you can see Andromeda. It's actually very big. Like, if you compare Andromeda with the size of the full moon, it's about the size of about 9 full moons. So imagine a grid of 9 full moons in the sky. That is how big Andromeda is, if you could sort of see it with the same level of detail as the moon. But you can't, because it's fairly faint and dim from our eyes, and yet you can see it with the unaided eye. And also in some other conditions, you can see another galaxy, another big galaxy. You can see M33. So you can see M31, which is Andromeda, and then M33, which is the galaxy in Triangulum. And that's a little harder to spot, and it's a little bit farther away. And so I would say Triangulum, with perfect seeing conditions, is the farthest galaxy you can see. Now, there are some other galaxies that you can maybe see, some of the ones in Ursa Major around the Big Dipper, but those are like the ones you can confidently see with the naked eye. Visto Tutti. Lee Cronin's assembly theory predicts life being probable common in the galaxy. Thoughts? Just a journalist, not a scientist. And so, you know, as a journalist, I would report that Lee Cronin predicts that life is going to be probable and common in the galaxy. Now, I did an interview with Lee Cronin a couple of years ago, and it was absolutely fascinating. He's such a creative thinker, somebody who just thinks outside the box with a lot of the ideas that he's working on. And so I'm going to sort of encourage you to go and watch that interview that I did with Lee Cronin. It's absolutely fascinating. It's like what he was proposing back then was a sort of universal way to search for life. What you do instead of like trying to spot any kind of physical process, whatever, is you just take all of the material that you can get your hands on and you just run it through a mass spectrometer, and you are just looking for complicated molecules. And the assumption is that life tends to produce more complex molecules than non-life. And so if you take a sample and you're getting a high incidence of complex molecules, then that is a sign that there could be life in your sample, and then you can then follow on with other methods to be able to follow. So it's an interesting conversation, and that's just like the beginning. Like I know Lee Cronin has come on to Lex Rubin's show a few times, and he's always a treat to listen to. Roadside Rebels, was the movie The Martian anywhere even close to the way it'll be on Mars? Yeah, The Martian was pretty scientifically accurate. I actually just recently watched The Martian about 3 months ago, and when I first read the book, I was blown away by how detailed and accurate the book was. And then when I watched the movie, they did a great job of telling the book, although there was a couple of things that were incredibly realistic and kind of frustrating because I don't want to spoil it, but if you've read the book and you've watched the movie, then you know exactly what I'm talking about Iron Man in the end. But the various bits and pieces of the movie were really done very, very well. The communications delays, him finding the plutonium RTG to keep himself warm, in the amount of solar panel power that he was able to get, and the time that it would take for cycles between Earth and Mars. Like Andy Weir did all of the math, consulted with scientists to get everything as right as humanly possible. Now, there's a couple of things that were unrealistic. The first thing that was very unrealistic was the windstorm. So in the beginning of the movie, there's this giant dust storm that blows up, and it is threatening to blow over the ascent module for the spacecraft, and it knocks Watney into the sand, and they have to leave him behind. And the reality is that on Mars, the air pressure is 1% the pressure that it is on Earth. And so you couldn't even fly a kite in a hurricane on Mars. The only reason that the Mars helicopter can fly is because the rotors are spinning at thousands of RPM, and they're making up for low air pressure with just brute force speed. So you could stand out in a really powerful dust storm, your solar panels would be covered, and you would have a hard time seeing around you, but the wind just wouldn't be that damaging. And Andy Weir admits that. Like when I talked to Andy about that, and he was like, yeah, no, I knew that was unrealistic, but I wanted a way to have him stuck that was very dramatic, and that was the one that he picked. So that's the big one. There were minor issues, but apart from that, I thought it was a really nice, accurate telling of what it would be like for a research station on Mars. Now, there's a few other things that are probably a problem, although, some of this is a little newer than what they knew back then. So, the regolith on Mars is filled with this very toxic substance called perchlorates. And so he wouldn't have been able to just grow potatoes in the perchlorates, kind of like growing them in poison. But you can wash the soil. So there's ways to treat the regolith on Mars so that you could get the perchlorates out and then be able to start to grow. But you couldn't just like dig it into the sand and go from there. And then the other thing, and this is sort of fairly new, is it appears that the amount of cosmic radiation and solar radiation that's hitting the surface of Mars is too damaging for plants to grow unprotected. And so the dream is that you've got this greenhouse and you've got your Martian plants out there, or your poop potatoes or whatever, and you're growing them outside and things are just great and they grow just like they do. Well, on Mars, the amount of light that actually falls on the ground is about 1/4 what we get on Earth. And so imagine how your plants would appreciate it if you only give them 1/4 the sunlight. But also, you're getting this damaging galactic cosmic radiation, which is incredibly dangerous. It destroys DNA, causes radiation damage, increases chances of cancer, as well as you're getting solar storms. And yeah, if there's like one solar storm, you're like, oh, there's a solar storm, everybody hide, right? And you go underground and you wait for the solar storm to pass. But you can't do that with your plants. Your plants are gonna have to remain out on the surface, under the glass, getting hit by the radiation. And so he probably wouldn't have been able to grow poop potatoes to keep himself alive. And I'm sure if we went with a fine-tooth comb and really looked through the movie, there would be other issues. But on the whole, it feels like one of the most scientifically accurate space exploration movies I've ever seen. Kudos to everybody involved. If you want to support the work we do at Universe Today, consider joining our Patreon club. Your support lets us have a minimum of ads and no sponsorship messages. Patrons get no ads on universetoday.com for life. Want the extra parts of the live stream that aren't in this edited version? You can sign up for a special patron-only podcast feed, get the overtime segments, as well as other special behind-the-scenes episodes, including our monthly patron-only question show. Thanks to everyone who has already subscribed, and welcome to the recent newcomers: Bruce Moreland, Bob Ramthel, Bart Flaherty, John Bush, Skooma, Joseph Kogan, Dr. Martin Bermudez, Valtz Treybergs, Caltrix, and Janine Anderson. Join the club at patreon.com/universetoday. Kim Barron, do you think von Neumann probes are doable with our current technology? No, not with our current technology. We are not capable of making self-replicating robot probes capable of traveling interstellar distances, and when they arrive at their destination, making more copies of themselves. Like, that is still deep science fiction compared to what we're capable of. But I don't think it's going to be a long time. The rate of technological advancement is exponential, and it is surprising how quickly things that felt like science fiction, smartphones, right? Like that's crazy when you think about what happened in Star Trek, where they had their communicators, and then they had some version of it. They had the little comm badges in Star Trek: The Next Generation. I mean, we could have those now if we wanted. I guess that's what people's watches are, but we have like the speed that technology advances, and you're seeing with large language models, with machine learning, with new kinds of robots, with 3D manufacturing, in space, that we're going to eventually get to some kind of minimum viable self-replicating robot within the solar system, where you have a little factory, it goes out, it builds a little more robots, and they move to all of the worlds inside the solar system. And I'd say we are, like, conservatively 50 years away from that, but maybe sooner. Like, maybe that's a 20-year, 30-year thing for us to be able to do. That big trick is going to be sending your spacecraft at interstellar distances, and that's where we're going to need big advances in technology to be able to pull that off in our lifetime. But computers don't care how long it takes, so maybe if it takes 1,000 years for them to get to another star system, we still will be colonizing every star system in the entire galaxy. And I would love to get the reports, right? Like, wouldn't that be amazing? Like, when I think about when you play some game like Stellaris or whatever, and you look through all of the planets, all of the star systems in your empire, and you can look at their worlds and the populations, all that kind of stuff. As those von Neumann probes are heading out and going to different star systems and self-replicating, and they're going to be sending all this data home, and we're going to be building this giant database that is a picture of every world in the entire Milky Way. And eventually, some future version of us, 10 million years down the road, will have a database of every single star system in the entire Milky Way, every planet, and they'll be able to just like, virtually sightsee these different worlds. And we can't do that right now. And that does make me feel a little sad that we are too early in on this process. Yes, we have the internet, we have video games, we have technology, we have all this cool stuff, but we're not going to be around for that next one, unless I get my robot body, of course. Corey K, can you speak to the shape of the known universe? Is it like the plane of our solar system? How can an object that is expanding in all directions not be a sphere? So the miscommunication, the misunderstanding out there is that the actual universe is a sphere, and it's not. The observable universe is a sphere. In other words, the region around you that you can see is a sphere, and that's only because light takes time to travel, and when you look in all directions, you're seeing the light that has taken 13.8 billion years to get to you, and that I have a different observable universe than you do. And yes, when we look out into that observable universe, then everything appears to be moving away from us. But if you go to any place in the universe, everything's moving away from everything else. And so it's really important to distinguish between what is the observable universe, the universe that we can see. And the analogy that I always use is, imagine you're staying in fog, you've got like a bright light with you, you see a sphere of fog around you. And yet if you move over to another place, you see a different sphere of fog around you. That is your observable fogiverse. And so it's the same thing in the observable universe, except instead of it being like fog that you can't see through, it's time that light has taken to reach your eyes. What is the real shape and size of the universe? Well, one possibility is that it's infinite, goes on forever. it's possible that our observable universe is just this tiny little ball inside this infinite universe that goes off in all directions. The other possibility is that it's finite, but that it wraps. And so if you go in one direction, you return to your starting point, any way you want to go. So like, what shape is that? You know, it's not a sphere, because we know that the curvature of the universe doesn't permit that. So it might be like a torus, like a donut. The universe is a big donut. And so you go follow any path on a donut and you return to your starting point. Maybe it's a cube. You just follow any path on a cube and you return to your starting point. Internet Doge. If aliens looked at Earth with a telescope and the light took over 65 million years, would they see dinosaurs? Yes, they would see dinosaurs. They'd have to have a very good telescope though. Carmen Williams, do you expect the next Starship launch to go into orbit? I mean, I don't like to speculate on this kind of thing, but it feels like that will be the next objective, is for Starship to actually accomplish the goal of super heavy returning and landing in the ocean, and Starship returning and landing off the coast of Hawaii. That is the next big challenge. And so if they have more explosions and they don't pull that off, then that is a failure, right? That is the failure. But if they pull that off, then the next step is to try and actually go orbital and test out a re-entry. But it might be like, SpaceX sometimes has a tendency to skip testing steps. So if they reach a problem and, you know, say the rocket tears itself apart and destroys their landing pad, instead of trying to recreate that exact test and trying to make sure they get it right, they will sometimes just skip to the next test. Because, I don't know, they learned whatever they felt they needed to learn. And so it could very well be that instead of them trying to recreate the mission that just happened, they're going to go straight to, we're going to try to go orbital and then re-enter the Earth's atmosphere, or we're going to try and land super heavy somewhere safe. So I like their chances. I don't know. I mean, how can we know in advance? I mean, it's just that it's difficult, it's complicated, it's expensive. There's so many ways that this can go wrong. We're just all gonna have to wait and see together. Liam, what and when is the next big space telescope scheduled to launch? So there's two upcoming space telescopes that I'm watching. One is, of course, the Nancy Grace Roman telescope, and this is the Hubble class telescope. This was one of those telescopes that was given to NASA by the National Reconnaissance Office. They had two leftover Hubble class spacecraft that they didn't know what to do with. And so they're like, we've got these kicking around. These two Hubble class space telescopes aren't good enough for the kind of Earth observation that we need to do. We were just gonna throw them in the trash. Do you want them? And NASA was like, yes, we'll take them. One has already been repurposed, but the other one is going to become the Nancy Grace Roman telescope. So it'll be the same size as the Hubble Space Telescope, but it has a really wide field of view. And so it's going to be able to image a big chunk of the sky. And its job is to help us understand the nature of dark matter and dark energy, to map the gravitational lensing at the largest scales. But it's also going to be equipped with this really powerful coronagraph, the thing that allows you to block the light from the star to be able to see the faint planets that are nearby. And it will be powerful enough to detect Jupiter-sized worlds orbiting around sun-like stars, which is outside the capability of any corona. Like, Webb can't do this, but Nancy Grace Roman will. And this is going to be the precursor to the upcoming Habitable Worlds Observatory that will launch in the 2040s. The other telescope that I'm really excited about is called Ariel, and it launches in 2028, and this is from the European Space Agency. And this is a telescope that's designed to categorize the atmospheres of extrasolar planets. So it's not going to be discovering new extrasolar planets, but at the time that it launches, there will be more than probably 10,000 planets known, and it will be attempting to analyze the atmospheres of as many of those worlds as possible. And so while Webb is able to do this, and we're getting reports every couple of weeks of new exoplanets that Webb has been looking at, Ariel is designed only to analyze exoplanets. And it's probably going to be able to look at 1,000 exoplanet atmospheres throughout its lifetime. And so we'll get a much better sense of what is the total amount of exoplanet atmospheres. What is how many contain these chemicals and how many contain those chemicals. And so I'm really excited. And also on board with the Ariel Space Telescope is going to be the Comet Interceptor. And this is going to be the tiny spacecraft, well, not tiny, but this is the spacecraft that's going to attempt to intercept an interstellar object. It's going to loiter at L2, wait with Gaia and Webb and Ariel, and then when some Oumuamua 2 is making its way through the solar system, it's going to fire its engines and attempt an intercept to fly past and gather a bunch of data as it goes by. And we'll get these first close-up images of a comet or asteroid that came from another solar system. So those are the two big telescopes that I'm excited about, but there's a lot that are in the pipeline. There's another one that's coming out of China. The Chinese are building their own kind of Hubble-class space telescope, and their original plan was to bolt it on to the Chinese space station, and they realized that, with all the shaking and all of that, it's not a great idea, and so they're going to have it fly in formation with the space station. And so whenever they need to do upgrades and improvements to it, they'll just dock it to the station, they'll spacewalk out to it, swap out the parts, and then they'll push it back out into space and have it keep doing its work. So there's a lot of really interesting missions that are coming up. Negroni, do we know anything about what NASA thinks about SpaceX's recent launch? I haven't heard any specific announcement of it yet, but I'm sure they're thrilled. Artemis 3 should be going to the moon in 2025, maybe 2026. It's going to be carrying astronauts to the surface of the moon, and their lander is going to be a SpaceX Starship, the human landing system. And not just any SpaceX Starship, but one that is custom designed for landing on the moon, one that has been refueled in Earth orbit from a special tanker spacecraft that it's going to take probably high teens of launches to refuel this spacecraft to be able to make this. So there's a lot of checks that need to be checked off to be able to get to the point that Artemis, when the Artemis astronauts arrive at the moon, they have a lander. And so every piece of progress that SpaceX can pull off to move them towards that goal, that is the deadline right now. The whole crushing deadline for SpaceX right now is to get the human landing system in place and tested before the Artemis astronauts show up. Because if it's delayed, then the entire Artemis mission is going to have to wait for that to happen. And there's a lot of money riding on this. I mean, they had a huge contract from NASA to be able to provide the landing system for Artemis 3. And so I'm sure NASA is like, come on, hurry up, get it done. Let's see some successful tests. And so I think people always feel like the government is holding back SpaceX, but I don't think it could be further from the truth. The government is relying on SpaceX to get this job done, to get Starship flying. And there's a lot of jobs and a lot of money and a lot of reputations are on the line. And any conversations that are happening with the FAA between SpaceX and NASA and the government, right? These are all happening to try and get this process going so that there can be a lander for the Artemis 3 astronauts when they arrive. I'm going to talk about The Martian some more, as well as some other books, but first I'd like to thank our patrons. Thanks to Dougie Stewart, Stephen Krasaki, David Richards, Mark Ansis, Joel Yancey, Antonio Lofi-Lara, Dustin Cable, Vlad Chiplin, Monso, George, David Giltonet, Andrew Gross, Jeremy Mattern, Josh Schultz, and Jordan Young, who support us at the Master of the Universe level, and all of our other supporters on Patreon. I was talking about The Martian in the episode, and last time The Martian came up, I decided, okay, that's it. I'm going to go and watch The Martian again, and just binge watched it with my wife. And it totally stands up. And I highly recommend that if you haven't seen it, you definitely should watch it. There's no chance that you haven't seen it, but if you haven't read it, I really recommend that you read The Martian. It is one of the best, sort of most entertaining science fiction books I've read in recent years. I read it, just consumed it over the course of a day. I gave it to my father. He read it, consumed it over the course of a day. I gave it to my son, my wife. All of them read it and really loved the book. And so, if you enjoyed the movie, I promise you the book is great. And then if you want another book by Andy Weir, I highly recommend Project Hail Mary, which it's about a sort of existential threat to Earth, and humanity sends a spacecraft to try and solve the problem, and shenanigans ensue. And it's great. Same thing. If you enjoyed, it is Mark Watney again, just with a different character name, but essentially it's the same character, but a different scenario and different problems to overcome, and very creative, very imaginative alien that he interacts with. I really enjoyed the book. So if you're looking for 2 books, if you just want no end of fun, The Martian and Project Hail Mary by Andy Weir. All right, we'll see you next week.